Hello everyone, so in this video we are going to solve a question of Leetcode, that is binary tree pruning. So let's start with the problem statement. Given the root of a binary tree, written the same tree where each subtree not containing a 1 has been removed. So basically in this question we have given a binary tree and we need to remove all the subtrees which are not having 1 in the subtree. So let's see the first example. So in the first example we have given this, so let's just copy it from here and paste it here. All right, so this is the first example, and if we check all the subtrees in this binary tree, right? So this is the binary tree given to us, and we need to return this binary tree, right? So if we check all the subtrees, right? So this is a subtree, this is a subtree, and this is a subtree, and this whole is also be a subtree, right? So we are basically having 1 2, or we can say this both are also a subtree, right? So 1 2 3 4 5 6, right? Total we have 6 subtrees here, right? So let's see one by one. So let's say this is a subtree. So in this subtree we have 0, right? We have 0, and this 0, like in this subtree we do not have any 1, so we need to remove this, right? We need to remove this. So we will just remove this node from here, and in this we have 1, so it's fine. Now let's check for other conditions. So this is also a subtree, so in this subtree we also have 1, right? So this is fine, and for this subtree we also have 1, so it's fine. So at the end we are just returning 101 as a tree, right? So I hope this example is clear to you. And one more thing you can observe from here is that we are basically checking from the leaf node, right? So we can conclude one thing from here, right? We can conclude one thing from here. The thing is that we just need to check the leaf nodes, right? We just need to check the leaf node, and for the each leaf node we just need to remove all the non one, or we can say zero leaf nodes, right? So we just need to remove all the zero leaf nodes, right? So if we are getting a leaf node which is 0, we will directly remove it from the tree, right? And similarly, or we can say recursively, we will run the loops and this will give us this tree, right? So I hope this example and the explanation is clear to you. If you still have any doubt in this question, feel free to comment it down. We are just using a recursive call, and in the each recursive call we are just checking for the leaf node, right? We are just checking for the leaf node, and if the leaf node is 0, we are removing that leaf node. Else, if the leaf node is 1, we are just keeping that leaf node, or we can say we are just skipping that step of removing the leaf node, and we will just move forward in the recursive call, right? So only the one step we need to do is, whenever we will get a 0 as a leaf node, we just need to remove that node, right? This is the very important step in this question, and this only we need to do in this question, right? So let's quickly code it up. I hope this is clear to you. So the thing we need to code it here is, so before that let's check if root is null, right? If root is null, then we will be returning null from here. Else, just traverse to the left and the right part. So root of left part is equal to, let's call the recursive function here, prune tree root left and root right is equal to prune tree root right. All right, so we have just called two recursive function for the left and the right side of a binary tree, right? Now the only thing we need to check here is, we just need to check the leaf node, right? So what are the conditions for this leaf node which we need to check? So the very first condition of the leaf node is, if the value is, right, if the value is equal to 0, right? If the value is equal to 0, then it is a leaf node, right? Then the second condition of the leaf node is like the left part of this leaf node, right? So we can say um, root left, if the root left is equal to null, right? If the root left is equal to null, then it's a leaf node. As well as if the root right, if the root right is also null, then only it's a leaf node, right? So if all these three conditions, right, if all these three conditions are true, then it's a leaf node and the value is 0, or we can say the value of the leaf node is 0. So in this condition we will be returning null, else we will be returning that leaf node, right? So let's write the same statement here. If root value is equal to 0 and root left is null and root right is also null, so in this case we will just return null from here, else just return root from here, or we can say that node from here. So I hope this code is fine. Let's try to run this on the sample test cases. Yeah, it's working fine. Let's just submit this. Yeah, it's running fine. So let's discuss the time and space complexity of our solution. So the time complexity of our solution is big O of n because we are traversing through all the n nodes, and the space complexity of our solution is big O of h. We can say h is the height of the tree, right? So this big O of h space is the auxiliary space for the recursive stack, right? So that is it for this video. I hope the solution and the approach is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.